Okay, this is the video for questions 5 and 6. Number 5a. Express f of x equals x squared minus 6x plus 14 in the form f of x equals x minus h squared plus k, sorry. So this is standard form, this is vertex form. Whenever you need to change from standard form to vertex form, you complete the square. Alright, so again, standard form to vertex form, complete the square. So let's do that. Here's our original function. Sometimes it's easier to rewrite f of x as y. I don't know. It just makes it easier, maybe because you're used to using y more often. So anyway, I've rewritten it that with y. Now to complete the square, I'm going to move this 14 to this side, negative 14, just so I have this side all by itself and I can do the completing the square there. Alright, so now to complete the square, you remember it's b over 2 squared. So you take this b value, divide by 2, and then square it. So negative 6 divided by 2 is negative 3. Square that, you get 9. So that value is 9. Now we know if we add 9 here, it's going to make what's called a perfect square, which is easy to factor. But if we add 9 on this side, we have to add 9 on this side also to maintain the balance on both sides. So here, when you add 9, you get y minus 5. Over here, when you look at that, x squared minus 6x plus 9, that's called a perfect square. And that factors into this, right? It's always the square root of that, this sign here, and the square root of that here. That's the perfect square, and that's how it factors. If you were to multiply this back out, you'd get right back to this. So now we've completed the square, and we've changed it to this form. I'm just going to move the 5 back onto this side. So there's the 5 there now. Now we have this form. It said, that's what it asked us to do. Turn this standard form into this vertex form, and that's what we have right here, the vertex form. So we're done. We've done that step right there. B says, hence or otherwise. Okay, whenever you see that on a test, hence or otherwise means hence means as a result of the work that you've done, all right, or otherwise would mean basically take what you've done and show something that is in contrast to that. But in this question, it's hence. Since we've done this, we can now write down the coordinates of the vertex. So as a result of the work we've done, this work, what is the vertex, or what are the coordinates of the vertex of the parabola with this equation? So this is the same parabola, and now it's saying what is the vertex? Well, by doing this in the first step, from changing it from standard to vertex form, we have actually found out what the vertex is, because this is called vertex form for a reason, because the vertex is really easy to see. It's right here and right here. So to answer B, the vertex is 3, 5. Remember that for the vertex, this is always the opposite value. So positive 3, 5. There's our vertex. Question 6. All right. This one's not too bad at all. Let's take a look. This is our original parabola. This is a new parabola. That's the result of transformations done on this parabola. And it even tells you what the transformations are. But the first thing I want to show you is when they've written this parabola in this form, we're not accustomed to seeing the equation written like that, so I'm just going to rewrite it a way that you're probably more used to seeing. It's with the 5 at the end instead, so negative 3x minus 4 squared plus 5. All I did is put that 5 at the end. It's a little bit easier to see now, and you can clearly see now where the vertex is again, right? Negative 4 and 5, so that would be 4, 5 is the vertex, and that's right, see 4, 5, there's the vertex at 4, 5. So this form might be easier to see. So now that we see that, we have to look at what happened. First of all, the original, this one here, x squared, was reflected in the line y equals 0. Where's y equals 0? Here's y, here's 0, y equals 0. So here's the line y equals 0. It's actually the x-axis. This thing was reflected across the x-axis, it says. So that means take this whole parabola and flip it over the x-axis. That means it's going to end up down here like this, pointing down. And that makes sense because when you look at the final parabola here, it's opening down instead of opening up like this one. So we know it flipped that way. So there's that reflection. Then it says followed by a vertical stretch. Vertical stretch is stretching it up and down, right? And the scale factor is k. Alright, so if you remember, the number in front of the function is your vertical scale factor. It's the one that's going to expand it or stretch it. And we see a 3 here. Alright, next, a horizontal translation of p units. Horizontal means left, right, right, along the x-axis. horizontal translation of p units. So this flipped over, and then it moved over, and you're like, well, how many units? Well, that vertex went from to there, 1, 2, 3, 4. The vertex moved over 4, and we can see that 4 right here. All right. Finally, there's a vertical translation of q units. So vertically means up and down. All right, now you look at this parabola, and you're like, well, how much did it move up? It went 1, 2, 3, 4, 5. To get to here, it moves up 5. So imagine it flipping first, then being stretched, and then moving like this, moving like this, and it end up here. So anyway, all the numbers you need are right there. They're given to you. This question, you don't have to solve anything. You just have to look at the equation you're given and consider what the numbers mean. So first it says write a value of k. K is your vertical stretch. This number here tells you your vertical stretch. And you're not going to put negative. The negative is because of the flip, the reflection. The 3 is the stretch number, so k equals 3. P is your horizontal translation. So that's moving along the x. This number tells you how much it moves along the x. And this is negative, but it moved for positive along the x, so p equals 4. And then q is your vertical translation. So how much did it go up and down? And this is a number, remember, that tells you how much it moves up and down. So it moved up 5. So q is 5.